Our next session is going to focus on when things get complex systems challenges and where to focus. And it's my pleasure to introduce our next speaker, Georg Dahl from McKinsey, who's going to walk us through this discussion. Welcome, Georg.
Hey, thank you, Chris, for welcoming me. Let's see how this works with the presentation. I can just move forward, backward. Yeah, very good. Okay. Yeah, thanks everyone. And I'd like to talk a bit about what happens if things get complex. So my name is Georg Dahl. I'm with McKinsey in Munich. Many people here may know me. I've been in the Geneva Alliance from day one, and really happy to have the opportunity to present to you here tonight. The next two slides are basically just for you to read when you have the presentation at hand. What are we talking about? It's really about software and what happens to software. And one thing that is becoming very clear is software is on the rise, and it is a complex beast to manage. And that's not just me saying that. I think everybody in the auto industry is starting to realize that, how complex and how important software is. And a couple of statements that I'd like to show here in the intro. So Christoph Grote, several years back already, made a statement, something like 95% of the innovations in automotive is software-based. And just recently, Ola Colenio said we have to stay relevant, we have to control the software in our vehicles. And when you think about all that, and you talk about software, then one thing always comes to my mind, which is the value of software is not in the code, it's in the head of the people who develop the code. So this is something that I want you to keep in mind when we go through this presentation. But before we start any technology stuff, let me quickly talk a bit about what we think about where the software market is going towards. So when we look into software or electronics as a whole market, we definitely see a significant growth over the next year. So we expect some growth, an annual growth of about 7%, which is large. And to a large extent, it is actually not dependent on the amount of vehicles that we are selling, but it's really on the engineering effort. If you want to think about what's happening right now with the industry, of course, there's always some uncertainty in these numbers. But there's a couple of things that I'd like to dive in. If we look, for instance, on this specific area in the middle, this electronic control units and domain controllers, I think this is one of the very interesting developments here, is that we actually see that the number of control units in the vehicle is stagnating or even shrinking then again, and that the centralization of the vehicles is happening. So it's not only happening for one or two OEMs, it is actually really happening across the board. It's basically nearly every OEM is in this way right now, and we bring more and more software into the vehicle. Why is that so? Now, there are four reasons, main activities that happen right now. There's ADAS and autonomous driving, there's connectivity, there's electrification, and there's shared mobility. And all of our OEMs are very active in all four of these areas. And each of these areas is really based on software. With each of these areas, we need more and more environmental awareness of our vehicles. And our vehicles have more and more sensors that we need to consider in our architecture. And these additional sensors, of course, make this whole thing more complicated. But it's not only the technology that brings us more and more features in. There's also something which we see coming through the regulations. Emissions, especially here in the US and also in Europe and in the US, are driving us forward. There is a lot of things in terms of electrification that drives us, new infrastructures, completely new change of the whole powertrain. The whole value chain is changing, and there's a lot of new functionality actually coming into vehicles. And when we think about that a bit more, and what we did there is we took a bit of a deeper look into our databases and what we have inside them. We have one database that's particularly interesting, in which we are monitoring software development. We're benchmarking software development. And we have two, from my perspective, really interesting analytics out of that. The one analytics is around the productivity, and the other one around complexity. So what we do in this is we basically standardize software. We take a project, we look into how much requirements there are, how many dependencies, how many interfaces. And out of these parameters, it's over 50 parameters, we calculate what we call a complexity number. And from this complexity number, we can then look into how companies are performing. So we can say how many complexity points per week, per man a company is producing. And we can also count in the sheer amount of number of projects, how the complexity is increasing over time. And the interesting thing that we see here is actually, you see the productivity with the dashed lines and the complexity with the completed, with the solid lines, is that there is a gap, and it's a widening gap. It's not consistently across all technologies and industries. It's actually quite interesting if you look on the classic software industry. So IT, the big players of the world, and we can definitely see, if it's normalized to 10 years ago to 1, you can definitely see that the complexity has been rising. But we can also see that the productivity actually came along, and there was a gap, or there is a gap, which means there's more and more people that need to work and fill this gap. But if we look in automotive, we're not doing as good. So if we look on mission critical things, this is basically safety relevant projects, we see that the complexity has been increasing significantly over the capability that we have been able to increase the productivity. And I think this is a learning that everybody can actually also see in his real life when you think about how big the teams are versus how big they have been in the past. There's a huge gap. But there is also a lot to learn. One of the things is we can do much better in productivity. And basically what it means, we have to manage two things when we talk about complexity. So we have to talk about how we manage the increase of complexity. What measures can we take to reduce the impact of increasing complexity? And the second is, what can we do to increase the efficiency of our teams? And why are some industries better than others? And I want to give a bit of a color to that during this presentation. So when we look into complexity on the technical side of the complexity, so what can we do to minimize the complexity? We see about 7 main drivers there. They range from portfolio management to lifecycle management, and it starts with a functional redundancy. So if you look on vehicles today, very often we implement the same functions multiple times. Some have identified that and work against it. So for instance, the number of locations where we calculate the speed of the vehicle. Versions and variety. Multiple versions of the same application at the same time. So we have multiple other systems with only little variances. Yet we have to maintain and develop them. Interfering subsystems. We throw everything together. One system interferes with the other. And the result is that they become unpredictable, and the integration effort goes up. Closed systems. So when we talk about how we build control units, we build them for one specific vehicle launch, and we put everything in. It's tightly integrated. If you want to reuse something, it is actually quite complicated. We have point-to-point interfaces. Everybody talks to everyone. We don't have a communication strategy at hand. It's not like that we try to work in layers. There's multiple hardware platforms that we support, multiple operating systems. In the same vehicle, you're going to find 5 different variances of AUTOSAR, 10 different variances of Linux. And these are elements that we can actually think about how we can actually maintain that. And then last but not least, code documentation and quality. I don't need to talk about that. I want to dive into 2 of these elements a bit further. The first one would be this interfering subsystems. So when you build a system and you build it in a way that it actually interferes with the other systems, then what happens is that your complexity is actually going exponential. It's actually a function, a faculty function. So you have a system A. The system A has a couple of test cases. You have a system B, and the system B interferes with system A. That means you're going to have to, if you want to really introduce the cover all test possibilities, you're going to have to test system A under all conditions of system B, and this is going to give you an exponential curve in the complexity, in the amount of testing that is required. And I'm only focusing on testing here just to give you an example. Now, on the other hand, oops, this is somehow jumping, sorry. On the other hand, if you look into the a fully isolated function, so if one function A and one function B is not dependent on each other, makes no sense because then they don't interact. But if this is the theoretical low limit, that means you only grow the effort with the number of functions. So it's a linear function. So you're going to be somewhere in between. But as you can see, if you want to do software updates over the air, if you want to maintain a fleet in the past, and you have a lot of variances, and you haven't thought about how you isolate your functions, how you keep them separate so that the impact of against each other is small, you can end up in a validation nightmare. The second topic that I'd like to talk about and do a little bit deep dive is this point-to-point interfaces, and I talked before about it. I mentioned it briefly. We don't have a communication structure. We have point-to-point signal-based communication. We're starting to do service-oriented architectures. We've done that here in Geneva for a long time, and we started to build communication layers. And this is something that is only happening recently. We are still deeply integrating our control units, even the domain controllers, vertically. So we build one domain controller and it fits exactly into one vehicle. We build the next vehicle, we build the next domain controller. We're not having independent life cycles of the different releases. I always ask my clients when I discuss this topic, I always ask, if you develop an Android application, how many people from Google will you have in your Scrum team or in your product increments if you do safe? Exactly 0. Why? Because we have entirely decoupled life cycles of these different architecture layers, and the mobile industry managed to do it, and several other industries have managed to do it. We still build vertically integrated systems, and this is one of our challenges in managing complexity. These are elements that we look into. And when we talk about where are we moving, how do we fit all these together, then what we can see is that we're really moving away from these isolated functions that we had in the beginning. We go over collaboration of ECUs, we go to cross-functional connectivity. We are now at the stage where most of the OEMs are centralizing their compute. We haven't really gotten to the point where we really are, or the computer on wheels, where we have this IT-like horizontal layers that are really on a different life cycle. There's only a few companies that actually act in this direction. And that is one of the things that we need to do in order to battle complexity. How do you go there? So we said, yes, there is this need for horizontal applications. We need to deeply understand software, because otherwise we won't be able to manage that complexity, that dependencies internally. We can't drive the reuse, we can't drive the dependencies between them. So how do we do that? And actually we get this question quite a lot. And it's not uncommon if you are in a company where this question is also raised, and you're really struggling with that. And there is not necessarily a single answer to that, but I'd like to show you a bit about what is it that we need to focus on. So first, again, our database. We looked into how does this actually look like from the database? How are different companies, and here's an example of automotive companies, so embedded software projects that we have in there. And what we can actually see is that if we take the average, so the median at 100, then we see that the best productivity, the companies who have the best productive people, so that's complexity units per man week, they are a factor of 2.7 more efficient, these people, than they are in the least quartile, in the lower quartile of the companies. If we take this even a step further and say how many complexity units per week does a team produce and a company, or how are the performance company working. Now, then we see that it's even more. It's a factor of 3.4 between the top performer and the low performer. And when we talk about residual design defects, it is actually also a quite interesting point to see how many problems are residing in the software that is delivered. And there is again a huge difference between the low performer quartile and the top performer quartile, which is over 83% difference in how they deliver software. Now you may ask, oh, how is that happening? How could this happen that we have a totally different picture in this landscape? And what could be the, well, rationale, or how can we actually grab that? So in order to answer that question, we developed something that we call Developer Velocity Index. And it's an index where we ask companies on how they're performing and what they think they are actually good in and why they think they are good in. And if we take that in combination with the other numbers, the result is actually quite interesting. So the questions are around 34 different drivers across 3 dimensions. So we talk about technology, we're talking about working practices, and we're talking about organization setup and enablement. And when we look into the result looks like something like that. And we've been talking about technology before a lot. And here at Geneva, we typically talk about technology, about architecture, about synchronization, about common electronics, car interfaces, and so on and so forth. So where do we find architecture again? Up there it is. It's actually not that important if you look to all the other bars here. It is actually something, yes, I wouldn't say neglected, but there are a lot of other things that are more important. Okay, let's say what is really important to us. So one of the things that I guess is really important, we're going to have to deliver compliant products. If we are delivering a car that isn't compliant to regulations, we are in serious trouble. Okay, let's say we do this, but then there are still other things that are even more important than compliance in order to be in the top quartile of the companies. And let's dive into what that is. The first thing is, interesting enough, in technology, it's not the actual thing that we build, it's the how we build it. What tools do we have? Do our engineers spend times in Excel, in PowerPoint, or do they have tools that enable them so that they are working efficiently? The second thing is organization, product management. Are we building the right thing? If we're not building the right thing, a lot of work is for the trash bin. So it is really, really important to understand who is our customer, what are we building for our customer, and what is this actual work product that we here create. What's the next cluster? The next cluster is company culture. So we all know software is complex, and we know that one thing to navigate complexity, what can help is working in an agile development environment. But agile means learn. It means allowing to fail. Failure is an option. Failure is something that we can use to learn from. And best is if one fails and everyone else can learn from it. And this is part of this cultural topic. So how is failure accepted? How do you actually embrace and how do you care about your people? And the care about the people is actually the last bullet here, which is the last couple of bars that go and are more important than even compliance, is talent management. So how do you go about your people? And with that, I'm nearly coming to a conclusion. We say there's 4 key success factors that we consistently see in companies that are in the top quartile. And it is culture, it is talent management, it's development tools, and it's product management. It is basically focusing on the right job and then enabling your people. And now let's go back to why I said you need to keep that in mind. The value of software is not in the code, it's in the head of the people. So software development is not a technology thing. Technology is enabling, it's a people thing. And I think once you understood that, you're on the right path towards the top quartile of our companies. Thank you. I hope that helps. It was a
That's
bit of
great, Georg. Thank you for that
a couple of
overview.
thoughts to think about.
No, this is fantastic. If anyone has questions for Georg, please feel free to put those in the chat window or the question window, and we'll add those. Georg, I have a question for you. You mentioned vehicle electrification and autonomous transportation, obviously highly, highly complex activities. When you talk about software development and people, what do you view as the key priorities to the enablement of both vehicle electrification and autonomy that is clearly not an easy task? What's the balance of people, software, and how we're going to realize ourselves in these two advancements in transportation?
Yeah. I think these two elements, especially the autonomous driving, is an area where you have significant amount of more software than we ever had in a vehicle. If you think about the most complex system in a car for many, many, many years from a software perspective was the infotainment system. Now you look into autonomous driving, well, that is yet another category on top. We barely manage to do infotainment systems in the classical way of working, basically saying, these are my requirements, I throw them over the fence and someone else is developing that for us. And when you go into this much more complicated systems, it would be brute force to try to go through that. And we all know how efficient brute force interface things are working. So what it is again about team enablement, and it's also an understanding, an in-depth understanding on the OEM side what software means that is required. And in order to get to that answer, you're going to have to work with software companies, or you have to work in a software way. And here I come to your question. Maybe that's really my take on that. Is when you talk about it and you talk about what are the development tools, what are the interfaces between an OEM and a tier one or a supplier that supplies software, then it is much more than just a requirement document and at the end some testing. So you're going to have to think about how do you do your weeklies, how do you do your configuration management, how do you go into a contiguous build, how do you enable your software engineers to really understand on the spot what they need to do tomorrow. And I think this is a much, much broader interface between the suppliers and therefore more people talking to each other about more topics than we have done that in the past.
And you touched on something interesting about it's people, not just building software. But when we think about things like getting people comfortable with electrified transportation or getting people comfortable with traveling in autonomous transportation, how do you bring that human element into your software design and what the finished product is ultimately going to look like?
Also, you mean about the end user? How do you bring people in the end user? Well, that's
exactly like thinking like the end user who's ultimately going to consume the transportation, or utilize it.
Well, maybe you should use it yourself if you write that software. But I think this is actually one of the things when you talk about agile software development and when you talk about bringing the end user in, that is a clear objective of that you have to build something that is usable for an end user. But when you then look into these systems, how complex and how big they are, and you try to chunk them down, you're suddenly going to end up with a lot of stakeholders. And some of the stakeholders might simply be the factory. So you're going to have to build that thing. It has to roll off the end of the production line. There's going to be some validation work that has to be done. You're going to have to fulfill, you have other end users like homologation, where you have to be compliant to certain standards. So I think this end user definition, it is not only about the person that actually walks into the vehicle, which is actually in this topic product management. So how do you make sure that you're building the right thing? But this definition of user, I think we really need to widen that experience. This definition of user is really too narrow if we only look on the end user. And I'm talking now for the people that actually write software. They are very often very far away from the end user, from the actual driver or the passenger that's going to go into an autonomous vehicle.
Right. Gary, we have a question from the audience. One is, what is the impact of OEMs bringing more software in-house and the relationship to complexity?
Yeah, that's a very interesting question. And it is I would answer it like that. If you try to sell something or you do develop something for someone who really doesn't understand what you're doing, you have a very hard life. So with that, I am very grateful that the OEMs really embrace software and really understand what software actually means. I think this is a significant benefit for all of us, that the OEMs start to understand and start to dive into this topic, software. It is going to be a differentiator for them. And I think it is quite important, with regards to what I said before, how this interface between supplier and customer is actually going to look like. And we do need different interfaces than we had in the past.
Very good. As you look ahead to 2021, where do you see the biggest opportunities regarding collaboration in software as it pertains to electrification and autonomy? What can you see on the horizon that's got you excited for where we're headed next?
Yeah, I think right now we are in a situation where the OEMs really have to focus and put a focus out on what they are really going for. They are struggling from a couple of significant changes, like electrification is going to change the entire supply chain. The current drop in the vehicle sales is hurting their numbers, so they're going to have to really think hard about what are they focusing on and come up with a make or buy, or in which areas do they want to differentiate. I think at the moment there's going to be a bit of a pause on autonomous driving. This is something that has been underestimated in its complexity. I think many people thought it's easier than it actually is. And if funding are going short, we might hear statements like delays and things like that. I think what excites me the most is actually the electrification. I think this is something where a entirely new thing is happening. We have the performance of the batteries now today that you can actually build electric cars. And it's building an electric car is a totally different challenge. It's also a software challenge, by the way. Controlling an electric motor is a software challenge, much more than it is a gasoline engine. Much faster, much shorter cycle times, much more real-time requirements in an electric car. And I think that is one of the areas that's really interesting. What I think is quite important is on this, you hear this, is these initiatives about operating systems. There might be a standardization around that, and it would really make sense. Mentioned before, 5 different operating systems, 5 times AUTOSAR on the same platform. Why are you doing that? So I think that is where the OEMs are going to have to stick their head together and actually the old idea of Genevi, maybe embrace it.
Sure. That's a good segue. Another question that came in, what is your suggestion on OEMs getting into Android since it has a legacy of integration of several complex systems?
Yeah. So in this point, first of all, I've just looked into that topic quite deeply, and it's actually a wide trend. So it's only few remaining companies that are not going Android. Let's put it that way around. It is more becoming the question, am I going Android AOSP or am I going Android and then on top Google Automotive Services? From my perspective, on board, we're going to need 3 different technology stacks. We're going to need something for hard real time in the micro and low seconds response time. And that is a specific way of scheduling and handling resources. We're going to need something on high performance, also safety related, but really high performance computing, autonomous driving, safety functions like engine control or whatever. My engine is really already in the lower end, but safety functions, ADAS functions, where you need computing power, where you need neural networks, but you're going to have to do that in a safe environment, still real-time responsiveness, and then you're going to have the entertainment stack. So these are the 3 stacks. And I think in this entertainment stack, Android is the #1 operating system that everybody is currently going for. You have an easy integration into the existing ecosystems at home. If I drive my car, just got a new one, and I tell him, hey, Google, open the garage, it's actually opening. And that is something that the OEM had nothing to do with. It is basically really tapping into the ecosystem. And enabling these ecosystems is the key.
That's great. Thank you so much, Garrett. We are unfortunately out of time for this particular session, but I do want to thank you for this very thorough presentation.